Power electronics. Good morning to all. Triangular waveform generator. Circuit consists of two op-amp A1 and A2. Input is given to first op-amp non-inverting terminal plus point. In non-inverting terminal, resistance R2 and varied resistance R3 are connected. The output of op-amp A1 V01 is connected to input of op-amp A2 inverting terminal minus point. Capacitor is connected to feedback position. V0 is output. We obtain triangular waveform generator. Output. We obtain triangular waveform. Triangular waveform generator waveform. Input and output waveform shown in figure. First, given the input plus V saturation to minus V saturation, that is square waveform. Output of triangular waveform is minus V ramp to plus V ramp. The graph between voltage and time shown in figure. The amplitude of frequency of the triangular wave can be determined as follows. When the output of the comparator A1 is plus V saturation, the output of the integrator A2 steadily decreases until it reaches minus V ramp. At this time, the output of A1 switches from plus V saturation to minus V saturation. Just before this switching occurs, the voltage at point P is 0 volt. This means that minus V ramp is developed across R2 and the plus V saturation developed across R3. Minus V ramp divided by R2 is equal to minus into plus V saturation divided by R3. That is minus V ramp is equal to minus R2 divided by R3 into plus V saturation. Similarly, plus V ramp is equal to minus R2 divided by R3 into minus V saturation. The output amplitude of the triangular wave is V0 peak to peak is equal to plus V ramp minus into minus of V ramp is equal to plus V ramp plus V ramp. V0 PP, that is peak to peak, is equal to 2 into R2 divided by R3 into V saturation. The time it takes for the output waveform to swing from minus V ramp to plus V ramp. Plus V ramp to minus V ramp is equal to T by 2. From minus V ramp to plus V ramp is equal to T by 2. This time can be calculated from the integrator or output equation. V0 PP is equal to 1 divided by RC integral of 0 to pi by 2 into minus V saturation into dt is equal to V saturation divided by R1 C1 into capital T by 2. Capital T is equal to 2 R1 C1 into V not peak to peak divided by V saturation. Finally, we find T is equal to capital T is equal to 4 R1 R2 C1 divided by R3. We find frequency value T is equal to 4 R1 R2 C1 divided by R3. That is F0 equal to R3 divided by 4 R1 R2 C1. That is 1 by T. F0 is equal to R3 divided by 4 R1 R2 C1. That is frequency value.